you guys are doing great. Welcome back to the channel. I know it's been late a little bit for the next video, but we are trying to improve our speed and productivity. So yeah, let's jump into today's topic. As you might have seen from the title and thumbnail, we are going to learn something we have seen a lot in our daily life. So I'm assuming everybody has used the WhatsApp nowadays, or any other messaging apps, not only WhatsApp, but WhatsApp is pretty much famous and everybody has used it. So in WhatsApp, you have seen whenever you're sending a message to a person, so yeah, you might see when you type message and hit done or enter, right? You might see that message will get a single tick. That means it is sent. So as soon as the message receives on that other person's end, on their mobile or laptop or any device, so we would be getting 2 ticks, right? That indicates that it is delivered. So when user actually opens and see that, right, the 2 ticks will turn into blue color. That indicates that the user has read your message, right? So we have seen a lot like this. But have you ever wondered how things are working under the hood, like how things happening behind this single tick, double tick, and blue tick? Okay, we know that single tick indicates what, double tick indicates what, and blue tick indicates what, but we don't know how things are working under the hood. So today in this topic, guys, we are gonna learn how exactly the single tick, double tick, and blue tick works. Okay, so let's take an example. Okay, you are sending a message. Okay, let's say I'm sending a message, meeting at 5. So you might see a single tick, delivered, double tick, read, blue tick. So there's a pattern. There's a concept that called event sourcing. So this is going to use to get the single tick, double tick, and blue tick. Okay, what is event sourcing? Okay, basically on a simple term, event sourcing is something like logging an event about what happened rather than what it is. Okay, so for example, when we type something and send, right, we know that we have sent a message. Okay, but the event will be logged, okay, in our event sourcing pattern. So events are nothing but an action by the user. So for example, I have sent a message, an event will be logged, the message has been delivered, another event will be logged, the message is read, another event will be logged. So basically on a simple and shorter term, right, event sourcing is something like logging what happened rather than what it is. Okay, just remember this, logging what happened at the moment rather than what it is. Okay, event sourcing pattern won't care what the message is and what is happening. I mean what it is, like what the message is and everything, but it does logs what happened to that message, is what the status of it. Okay, this is what event sourcing is. So every other system uses this kind of pattern. Okay, and this pattern can be observed in a very famous book called Designing Data Intensive Application by Clipman. So I would really suggest that you would read that book. Okay, you'll get a lot of information about the systems on it. Cool. So for example, let's think about a simple scenario. Okay, you don't know let's think about a simple scenario. You don't know how the system is working. You don't know event sourcing and everything. So for a simple junior engineer, when we ask to build such things, right, so every junior dev, every engineer would think in a very simple problem, very brute force approach. That is a column. Let's say there's a table, okay, in the database, and he or she would think as a column called status. Okay, so there will be a message table where ID, from, to, text, whatever we have, metadata we require, all those are columns. There will be a column called status, and this is not wrong though, but we can't scale with this. Okay, so works, and I'm not saying it doesn't work, works for a very small, but it misses something. No history, no audit trail, we don't know when it was delivered, when it was read. Okay, all these things. And obviously this will fail in group chats. This will work in single chat and a very simple simple scenario. Okay, now this, let's say somebody have worked on this, and engineer worked on this, and he created a table message and added the column. Now the product team or product managers ask the questions, when was this message delivered? No idea, right? So status. So what engineer will do is the engineer will try to add a few more columns, like sent at, delivered at, read at. Okay, now another question comes in, show me every state in this message has been. Okay, we will get current state, but there are, so in this schema, right, we won't be having full history, we won't be having audit trial or previous states, right? The history is gone. So now comes the question, where do we store the this in our schema? Okay, so for example, we are messaging in a group chat. Okay, I have message meeting at 5. Okay, 2 persons read and 1 person is offline. Okay, now our schema, Now we need to log everything and we need all this data, right? So in group 2 persons, right, and 1 person is on offline. So what a typical junior devs will do, or any other devs will do, is they'll try to add so many columns, so many keys to that message interface. So read by Asha, this is very wrong. I'm not saying everybody does this, but few people will try to do this. Okay, read by Aisha, read by Rohan, so all this delivered by. So for each and every user, read by, delivered by, and read by user, our schema is literally bloating. It will be overflowing. Okay, so this is the wrong abstraction from the day one itself for me. So guys, when you are creating any applications, right, you have to think in a user's perspective as well as in the future scaling, not only the current. There might be scenarios where you might have to launch quickly. Their brute force approaches might work, but in order to scale, right, in order to build systems, in order to build applications that run and scales a lot and for the millions of users, right, you have to think and you have to write the schema very well. Okay, so I'll show you an example and a metaphor. So our bank system also doesn't store our balance. Okay, our bank system never stores the balance. So for example, let's say there's a passbook and we would be getting all the transactions. So for example, credit transaction, debit transactions, and you would be seeing the balance as well, right, which is reflecting the credit minus the total balance plus credit minus debit. So we'll be getting derived balance, right? Yeah, so we would be getting derived balance, sum of credits minus sum of debits. Now these are the transactions. Okay, because we never store, bank never, but the software behind the bank system, right, it never stores the balance, because the source of truth are transactions. Okay, the balance is calculated from the transactions. Okay, there's no column in a table in a database like balance, current balance, balance. Okay, this is what happens. So that's the part called event sourcing. So it has three rules. Three rules are: every change is immutable. That means you can't change it. Okay, with a timestamp event. So whenever you log event, right, it is static, can't change it, and it will have the timestamp. Okay, including seconds as well. So we can't edit or delete it. It just happened. Okay, be it of right or wrong, the event is happened. That's the rule number one of event sourcing. The second rule is the log is append only. You only add it, never mutate it. Okay, so for example, you sent a message, the log has been added. Okay, now you edit a message, right? This another log will be added. The same log will not be edited. So that's the second rule of event sourcing. You just add it. That's it. No matter what, it is right or wrong, the event will be logged. You will just add it. Okay. The third rule is state is derived from the log. Okay, never store the source, never store as a source of truth. So the rule number 3 applies to the previous example I showed you, like the banking system, right? So balance is never the main store. Okay, we never store the balance, but current state is derived from the logs, the transactions, credit, debit. These are the logs actually. So our current state is derived from those logs, right? So this is what the third rule meant. Okay, so this concept is already present in DDI, Data Intensive Applications, Chapter 11, which has been written by Clement. Okay, you can get the copy of this book, or you can get the online PDFs as well. There are a lot of resources in the online. You just search on it. Okay, yeah. The main thing is the production infrastructure. Okay, so now this is not only is being used in a simple messaging things. A lot of things are happening using this pattern. Okay, and this book, like Data Intensive Applications, has a lot of things. Okay, so now event sourcing powers LinkedIn's entire messaging activity. So LinkedIn's message is very scalable feature. So that is powered by event sourcing. In Stripe also, every payment is immutable event balance, is derived from that. Okay, and you might get some questions on interviews or on event sourcing as well. So it's better to read this book, Ticks. Okay, this is the whole event. There is a function, derivation function. Okay, I'm just naming this as a derivation function. You can name whatever you want, but again, this function will return our tick state based on the logs, event sourcing logs. Okay, so for example, there's a log called message sent. Some person sent a message. Okay, there's one more log happened, message delivered. There's one more log happened, message read. So now all these logs are append only. Okay, these are immutable. Now tick state. Okay, as soon as we hit the function, it will get all the logs and derive the ticks from it. Now currently, if you see the screen, all three events are logged. That means we would need blue tick, red, derived all from the events. Okay, it will be something similar like this. So for example, derive tick. If the log has, if log has message read, return read, message delivered, delivered, sent, sent, return pending. Okay, now let's see in this single recipient scenario where we would be logging events, right? So log event. So log dot, so whenever a message sent, there will be we have to push a event, type message sent to it. Okay, now again, after pushing the event, we have to again call that function and check what's our tick status, derive tick. Okay, what are the tick status? The first, there will be a sent single tick. The second, for the second log, there will be a tick called delivered, 2 gray ticks. There will be third message read, blue tick. This is how we need to. So no state mutated, no update messages set, trade is no query, nothing. There's no column itself, no query. The state is pure function of log. Same log, same tick. Everything. Now, so till now we have solved single recipient, sent, delivered, and read. We would be so we have already seen how to get single tick, how to get double tick, and how to get blue tick. Okay, sent, delivered, read. Now comes the question: group chats, right? Who determines the tick when 3 or more than people, okay, have different states? Like someone actually, so the message has been delivered to a few people, the message has been delivered to few not delivered to few people, they're in offline mode, some people read it, some people not read it. So all these, like how our tick derives. Okay, and what happens? Yeah, that's the second question. Now, what happens when the device has no network? Do events get lost? Okay. Duplicates. If user might have in different scenarios. So if network flips, the same event arrives twice. Do we double count it? Let's see this. Okay, group chats are where event source goes from nice pattern to this is only the pattern it needs. Because if we don't use event sourcing on single chats, right, still gonna work. But group chats we have to. Okay, in order to scale it and in order to get the right results, we have to use event sourcing pattern. That's why we say this is why you would choose it. Okay. Okay, let's take the real problem what we are facing in the chat. Okay, one sender, 3 recipients, 3 different states. So sender sends a message delivered to a person, message delivered to another person, but message delivered to the last person, but he's offline. I mean, that is not yet delivered. So, okay, so all these events are logged. Now one more events will be logged, message read by a first person. Okay, now comes the question, what does the sender tick show? Can you guys guess it? Okay, let's just look at it. There's a person called Priya who hasn't read it. Okay, we can't say blue tick. And for the gray tick, 2 of 3 have read it. We have to count every member of it, right? 2 of 3 only read it. That means we can't show gray also. 2 gray ticks until everyone has read. Okay, this is what we need to show. 2 gray ticks until everyone has read. The group is not a single recipient set; it's an aggregation of all of them. So now 3 recipient, 3 sublogs. One every. There is a function called every. So for example, 3 different recipients. Okay. Now we'll be sending a message. 3 different logs will be happening. 3 different sublogs. Like for person 1, there will be a log called sent. For the person 1, there will be a log called delivered and read. Same happens with each and every person in that group. Okay. Sent, delivered, read. Sent, delivered, not read. Okay. Now we have to aggregate these logs, these events. So there will be a simple function. Okay. Simple function. We would get all the list of array of recipients. Okay. We would be looping those on every. There's a built-in function for arrays in JavaScript. You can search on it. Okay. Recipients.every. We are reading. Also, this read set, right? What you were saying, it's a hash map which is stored as a separate as soon as read event is logged. Okay. We would be needing that for a group chat. So in the recipients, we'll be checking if the read set has that same recipient, then read or delivered. Okay. Group stays gray when until and unless every is not satisfied. That means until unless every recipient has event called read, until that moment the group stays gray with the 2 ticks. Okay. If every recipient in the group chat has a event called read, then the sender's 2 ticks will turn into the blue. Okay. Now how it is happening? Derive group tick. So there will be a function. We have to create a function derive group tick. Okay. Now, as I said, read set. We would be storing read persons in a hash map. Okay. Now we are checking for every recipient. Does this particular recipient has in the read set? Then read or else not. Until and unless it's satisfied, right? We have to show double tick with a gray color only. Okay. This is what happened. So as we said earlier, aggregation over an event log is a natural operation on event log. So basically, if you want to get some current state, right, we have to aggregate with all the events. Okay, this is what the beauty of the pattern is. Now, what we learned, okay, what we have covered so far. we have to pick the right abstraction at the start itself only. We have to think in a future perspective, what user is going to use it, how our app going to scale it, how our feature is going to scale it. Okay, so there's a saying that pick the right abstraction at the start itself only. Okay, now if you remember the starting, we had discussed that status column approach, but again it's very wrong. Like architecturally it's wrong, because for a single thing, for a brute force approach, it is very good, but for a group chat we can't scale it. Okay, it will get harder with group chats. Now event sourced approach doesn't get harder, the functions remain the same. Aggregation over an event log is a natural operation on that event. Okay, we'll just log in an event, that's it. We'll aggregate entire events at once to get the current state. So this is what you need to think, guys. So basically you have to think in a very system design perspective at initial position only. I'm not saying this will get this thinking will get initially. Obviously you have to practice a lot. Okay, now and let's discuss a little bit about offline thing. The client UI was never wrong, so it just had a small subset of different logs on the server. Okay, now let's say there's a device offline and message, there will be event logging in the local only, sent one, sent read. All these are offline. It is queued. Okay, there will be a outbox and all these events are queued in it. Okay, because now you're offline, right? You can't. So the message has been delivered and everything you have read also, but since you're offline, your server didn't know. Your server didn't know what happened, right? So this will be a queued in outbox. As soon as connection returns, that outbox will be flushed out of your device and it will be logged in the server. So existing log, it will append it. Send one log append, send two log append, read append. So events reconcile. Okay, no error dialogues, no loss rates. So for example, you might have observed a message has been delivered to you, but you never read it. Okay, and you are offline. So you go on the WhatsApp and you read it. Okay, as soon as you read it, right, event API call will be made to the server. Event will be logged of what? Read event. But your WhatsApp never says there is a server error occurred, the read event is not sent to server. Yes, because user doesn't care about it. User should not know about it as well. Okay, that's what all these events are queued in an outbox. As soon as the connection returns, that entire outbox will be flashed out of the server. Okay, and all the logs, everything will be appended to. Okay, now the main golden rule, as we have also discussed in previous slides, that there's a rule of this event sourcing pattern called immutable, right? Those are like events are immutable. So every event has an immutable unique ID. Okay, so whenever you log an event, right, it should has a event unique ID. Okay, no matter what, be it a wrong event, be it a right event, be it a read event, a sent event, whatever maybe, it should has a unique ID. So for example, client sends first message. Okay, message read event ID. See, if you see, event ID is something like, why unique ID is required? Because so for example, there might be a cases where network is not that stable enough in blips, right? Now if the message is sent with the same unique ID, the server will not accept that. Okay, it just directly ignores that. The user will not be notified on this, it will just directly ignore that. Okay, so something like this happens on server. If current event ID and the logs of event ID is same, then return this log, nothing will happen. Okay, because duplicate detected, reject silently, no double count, nothing. So here first write wins. So whatever request comes first to the server, that only wins. Okay, the rules. So as I said, every event is immutable. You can't change it, you just add it, that's it, with a unique ID. So we have to generate unique ID at the creation of that event on the device itself only. Okay, server just checks the stored events versus coming event. So till now we have learned the tick system. Okay, single tick, double tick, and group tick system, and we have also learned event sourcing. But we have to know when to use this pattern, when not to use this pattern. Okay, so when you are designing systems, right, you have to think, you have to ask yourself a question: do we really need that concept of design system? Okay, do we really need that? Okay, what problem it solves? How we gonna scale it? What happens if we don't have it? What problem it solves if we have it? Okay, we have to ask these kind of questions to ourselves. So event sourcing, use event sourcing only if we need history. Okay, replace audit. Okay, if it's just a plain CRUD app, right, this event sourcing will be overkill and bloating technology. Okay, we should not use it. There are a few cases, as you can see, in messaging, payments, and bank ledgers, order fulfillments, etc., etc. So that's why event sourcing pattern, event logs, pays for itself. Now coming to the simple CRUD app, editing a user, changing password, so and so. So not required. So just a simple update query is enough for this. Here's your challenge. I'm gonna give you a challenge, so drop your answer in the comments. I'll pin the best explanation, okay, in the comments next week. First scenario: a message read event arrives in the server before its corresponding message delivered event. So that means the message, so you have sent a message, the third party person has directly like as soon as it delivered and it read it. Okay, that means the third person is already inside the chat of yours, for example. Okay, so when you type something and you see quickly, you'll see it single tick, double tick, and blue tick, right? You'll see quickly that happens. This is the scenario: a message read event arrives at the server before its corresponding message delivered event. Okay, now does this break derive trick? Whatever the function we have read, right, we have written, right, does that function works here, or does it break, or our logic has any issue or any bug? Guys, please work on this. If you didn't understand the entire this function derive trick, please go through, watch the video again, and try to get understand. Take a pen and paper, understand in a systems way, understand in a thinking way. Don't just write a code. Your job is to not write the code. Your job is to think. Your job is to solve the problem. Your job is to think in a very scaling perspective way. Okay. Also, there's a hint. Look at if order in derivative. Okay, there's a order as well, right? Read this check first. Why does that matter? So, guys, you will get to understand once you have an idea of what derive tick function does. That's it for today's video, guys. I hope you guys have understood how the messaging tick works, like single tick, double tick, and blue tick, how the pattern is working and what the pattern is. If you still want to read more about the event sourcing pattern, you can read it on designing data intensive applications book. So, and you'd be getting a lot of examples in the internet also. Try to answer this challenge, try to solve this challenge, and let me know in the comments. Thank you for watching. See you in the next video. Bye bye.